student, this is Manisha Tomar on my YouTube channel Chemistry for All Exams. My dear student, in this part we will discuss tests for aldehydes and ketones. How can we distinguish aldehydes and ketones in laboratory as well as in normal theoretical concepts. First test is with the Sif's reagents. When Sif's reagents react with aldehydes, they give pink color. Just take a little bit aldehyde in a test tube and add Sif's base on that. If you find the pink color, that indicates that is aldehyde. Second one, if there is ketone on the sample, that will not give any color. So there will be no color, that indicates that is ketone. So with the help of Sif's reagents, you can easily find out in laboratory which compound is aldehyde or which is ketone. Second one is the with Fehling solution. Very easily test. Fehling solutions gives red PPT with aldehydes while no PPT precipitate with ketones. So it is also very simple. Just same method is there here. Just take a little bit sample that will be aldehyde or ketone and add some amount of Fehling solution on that. If you will find red PPT, that indicates that is any aldehyde. After that you can find that will be formaldehyde, acetaldehyde or any other aldehyde. Next one is the with tolerance reagents. Tolerance reagents, that is silver solution, black PPT or silver mirror is formed. Aldehydes give silver mirror. Silver mirror means you have taken a test tube and take a sample that is aldehyde or ketone. If you will find silvery mirror means a shining surface on the test tube, sample's test tube, that indicates presence of aldehyde in the compound, and there is no black PPT or silvery mirror is formed with ketones. So first, Sif's base does not give reaction with ketones. Fehling solution also not give reaction with ketones, and tolerant reagent also not give reaction with ketones, while aldehydes gives all these three tests. Next one is the with saturated sodium sulfite solution in water. Crystalline compound that is colorless is formed. अगर आपने if you are taken any aldehyde and add saturated sodium bisulfite solution in water with on that compound, you will find crystalline compound which will be colorless, and crystalline compound colorless is formed also in the ketone. So there is a similarity in both condition. We find crystalline compound which will be colorless either in ketone or in aldehydes. Next one is with 2,4-dinitrophenyl hydrazine. Orange, yellow or red well defined crystals with melting point characteristic of individual aldehydes, while orange, yellow or red well defined crystals with melting point characteristic of individual ketones means both gives test with dinitrophenyl hydrazine. With sodium hydroxide, give brown resinous mass, miss except formaldehyde. Formaldehyde cannot give this test, which is sodium hydroxide, while other aldehydes gives this test with sodium hydroxide, while ketones does not give any test with sodium hydroxide. Next, with sodium nitroprusside and few drops of sodium hydroxide, a deep red PPT gives aldehydes except formaldehyde. Formaldehyde does not give this test also, nitroprusside test, while ketones gives red color which change to orange later. So these are the differences, and there is some also similarity which indicates aldehydes and ketones. So dear student, this point is important for the laboratory as well as examination perspective. Thank you so much.